Okay, hello everyone in a new video. Then we have reached part 4 of chapter 1. Okay, hello everyone in a new video. In this one we are going to explain part 4 of chapter 1, which is the chapter of electrostatics and the first unit of electricity for grade 10 students. Then now we have reached section 7.3, which is electrification by non-contact. And this is known as induction. Now previously we have seen that conductors can be charged by contact, not by rubbing. Now another interesting method of charging is charging by non-contact, which is induction. Now I'm gonna briefly explain the method, and I'm gonna write different statements. Now as you can see, the neutral conducting sphere that we have previously should be placed on an insulator stand in order to ensure that no electron gonna escape this process or during this process. Now what we're gonna do, the same ebonite rod which is negatively charged, which is brought previously in contact, now will be brought near to the sphere separated by a certain distance. Now what can happen is that this neutral conducting sphere that has no deficit access, but the thing is that it has positive and negative charges. Now we know that plus and minus attract, so opposite charges attract, like charges repel. Now the thing is that because this is negatively charged, it's gonna attract the positive charges. So because this is negatively charged, the positive charges will accumulate here, and the negative charges will accumulate here. Now one can ask, since positive charges don't move, how they're gonna accumulate here? The thing is that negative charges are migrating from this part to this part within the sphere itself, leaving this positively charged and leaving this negatively charged. So in other words, we can directly say, since this is negatively charged, the positive charge will be attracted to this side and the negative charges will be repelled to this side. So as we can see that an isolation of charges has occurred at the surface of the sphere. Now, till this moment, because the title of this section is electrification, till this moment the sphere is neutral, it's not electrified. How we're gonna make it electrified? Simply by letting these electrons escape through any conductor, and simply this can be done by touching this place, and this is known as grounding. By touching this location, which is the extreme opposite of the ebonite rod, all the electrons will escape across our body, since we are considered as a conductor. Now the positive charges that are located here will experience a force of repulsion, which is similar to the transient and static state, and the positive charges will be distributed along the outer surface. Okay, so this is it, basically the electrification by non-contact, which is induction. So please let me repeat and say that positive charges, they don't move now, so it's due to the motion of electrons what causes such processes. Now let me write statement number 1 is that electrification by non-contact, and this is known as induction, let me say, is used to charge conductors. Now in number 2, an ebonite rod negatively charged is brought near a neutral conducting sphere. And let me say also, if you want, without being in contact. Now in number 3, let me say an isolation of charge occurs on the sphere let me state statement number 3.1 that positive charges will accumulate close to the rod and this is because plus and minus attract and this is due to the charged ebonite rod. Now let me explain this again because this is negatively charged, the positive charges will accumulate close to this negatively charged rod. Now in 3.2 negative charges will repel or let me say will accumulate on the extreme far region because minus and minus repel. Now moreover let me say that in 3.3 this is just an isolation of charge, so let me say till this moment the sphere is neutral. So and what happened so far is nothing but just isolation of charge. So okay, then now in number 4 let me write by touching so by touching let me say the negatively charged region electrons will escape through our body and this is because a human body is considered as a conductor. Okay, and let me stress on the following fact. So here what I'm saying is that because these are accumulated here, we can simply touch them and they're gonna escape, and this process is known as grounding. Now number 5. So by that, electrons gonna escape the sphere through our body. Electrons on the sphere escape, leaving it. Now here it refers to the sphere positively charged, and transient slash static state similar to section 7.2 will occur. Then let me discuss here the transient and the static state. So let me say transient state. So we know that the transient state is the state of motion. All positive charges being found on the positive region will experience a repulsion force and a redistribution of charge will occur. And regarding the static state, is that all positive charges will spread on its outer surface. So basically this is the method of electrification by non-contact, which is used to charge conductors also. And now we're gonna move to an important section, which is section number 8, and this is an instrument which is the electroscope. Now remember that previously whenever we electrified either the ebonite rod or other objects, the evidence that these bodies are electrified the evidence was is that we try to attract small pieces of paper, if they are attracted, then these bodies are said to be electrified. But as we know that this method is not practical in any sense, so for this reason they have invented the electroscope. The electroscope consists of two main parts: the body of the electroscope, which is an insulator, basically a transparent body made up of glass, and the knob, stem, leaf system that are considered as a conductor. Then let me write the different parts of the electroscope. So the electroscope is an instrument used to detect the presence of electric charges on a body. Now, statement number 2, on the electroscope consists of, so 2.1, a conducting knob, so the knob is a conductor, and 2.2, a conducting stem that connects the knob to the leaves. So notice that the knob, now the stem, the leaves, they're gonna be a conductor, the stem is a conductor, so this is a knob. So all three are conductors, they are connected to each other. So let me write 2.3, that the leaves are conductors and in 2.4 the conducting stem is connected to the body of the electroscope to ensure that no free electrons will escape. So notice that the knob, stem, leaves conducting system is connected to insulator because in order to ensure that electrons won't escape. And now let me mention the following. So statement number 3, the leaves of the electroscope usually made of aluminum So aluminium foil are very light. Now we're gonna see why they are very light in weight. They are the only part made to move freely in the electroscope. So after we have justified the different parts of this electroscope, now we mentioned something about the leaves, that these leaves can move freely and they are very light in weight. So they play a similar role to the clips, to the paper, to the pieces of paper or to the paper clips. So but so now we have just introduced the different parts of the, so the leaves are hinged here and they can move like this, so either diverge or collapse back, so they can rotate or move backward and forward. So but yet we didn't justify how can one use the electroscope. So this is section 8.1. Actually the electroscope can be used under two different modes, and now we're gonna discuss the first mode, which is electrification by, so electrification by contact, or let me say 8.1, that this is electroscope under conduction mode. And now what's gonna happen is the following: a negatively charged ebonite rod will be brought in contact to the knob. The electrons will migrate from the ebonite to the stem, to the knob stem leaf system. They're gonna reach the leaves, which is very far away, and because these two very light leaves carry negative charges, they will repel, because like charges always repel. When they repel, this is an indication that the ebonite is initially negatively charged. So let me write number 1. A negatively charged ebonite rod is brought in contact with a neutral electroscope. And this important thing that I have mentioned here, this is a neutral electroscope. So how do you know that this is a neutral? The leaves of the electroscope must look something like this. Okay, they are close to each other. Now in number 2, electrons will migrate from the rod to the knob stem leaves system. Now number 3, the knob, or sorry, the leaves are now negatively charged and let me say, so they are negatively charged, and since it is the only movable part, they will repel, keeping the same divergence. So now for sure the ebonite is brought in contact and removed away. We can notice that the leaf will diverge, keeping the same. So we repel, keeping the same divergence. Now for example, if you want to neutralize the electroscope again, what we're gonna do is the following. The electroscope can be neutralized by grounding, and here by grounding I mean we just can touch the knob. So by grounding we can write between the brackets touching the knob, and the leaves by that will collapse. Now if we touch, so suppose this is removed away, if we touch the knob, so the electrons that are found here we're gonna escape across the knob, and by that the leaves gonna carry no more negatively charged particles or the electrons, and by that they will collapse again. So this is the electroscope under conduction mode. Now also the electroscope in section, let me see, 8.2 can be used electroscope under induction mode. Now here what we can do is the following. Without the same negatively charged ebonite rod, without being in contact, it can be brought near this neutral electroscope. So it is neutral, so it doesn't admit any deficit or excess, but it has positively charged particles. They will be attracted to the negatively charged, and the negative charged particles will be repelled to the leaves, and the leaves will diverge, which is an indication that the rod is negatively charged. Now let me write number 1. A negatively charged ebonite rod is brought near the knob of a neutral electroscope. Now the following will happen. An isolation of charge occurs in the electroscope So let me say statement number 2.1. Negative charges, positive charges will accumulate on the knob in 2.2 negative charges will accumulate very far away, and by that we means that they're gonna accumulate at the leaves. So now, because since it is the only movable part, they will repel, keeping the same divergence. And suddenly, without the grounding, just now, since this is just an isolation of charge, it is neutral overall. By removing this rod away, so let me say, on the electroscope, is the neutral so far. Removing the rod far away will cause the leaves to collapse even without the grounding. So that's it for me in this video, guys. In the next part 5, we're gonna solve some exercises on what we have discussed so far.